Hello guys, welcome back once again. In this video, we're gonna discuss about the EmSAT Achieve Chemistry Test specification, the latest one which is updated by the Ministry of Education for the year 2021. So this is the latest one which is available so far. And thank you so much for your feedback and the comments on the videos which I have uploaded for EmSAT Achieve Math, EmSAT Achieve Physics, and so on. So I'm trying to implement it based on the request of the students. So here I started today to doing it to the EmSAT chemistry. So here we're gonna discuss about the questions and the concepts behind each and every questions for the better understanding of the subject. So let's start. Question number 1 here is, compared to the charge of a proton, the charge of electron is. As we know that proton is a positive charge and its value is charge of a proton, we can say it as plus 1.6 into 10 to the power negative 19 coulomb. So it's a positively charged particle, and electron we say it as negatively charged particle. So charge of an electron is minus 1.6 into 10 to the power negative 19 coulomb. So question are asking us, compared to the charge of a proton, the charge of electron is. You can see that compared to the charge of a proton, the charge of electron is negative. So I should go equal and opposite in sign. So they are equally charged, but there. Question number 2 here is, chlorine atom is in an excited state when an electron in this atom jumps from the fourth to the third shell. Energy is. So whenever the electron jumps from the higher energy level to the lower energy level, the energy will be released. This is according to the Bohr model. So for example, if you are representing the different energy levels of an electron, if electron is in the higher energy state and it is jumping from the higher energy state to the lower, no matter it is 4 to third, 4 to second, wherever it. So whenever it jumps, it radiates the light energy of different frequency. And how do we give that value of that energy? According to the Bohr model, the amount of energy released equal to E is equals to H into V, where H is representing the Planck's constant. It's we say the Planck's constant value, and V is representing the frequency of the light frequency. So that is how the energy of the electron is depending. So it radiates the energy, it releases the energy. So we go with A as an option here. Question number 3 here is, one of the most important properties of mixture is that may have different proportions of their components, and second option says have fixed proportion of their components, can be separated only by chemical means, are very reactive and unstable. So as we are talking about the word mixture, mixture is basically the combination of different type of compounds or different kind of elements. I can say the mixture of hydrogen, helium and nitrogen gas are. So but how their concentrations, we can't say that all the gases has to be with their equal proportions. So we should go, the mixture may have different proportions of their components. So when we are talking about mixture, it's a mixture of different types of elements, or we can say molecules, but there is no fixed rule that they have to be in the same proportions. Their proportions, their concentration could be different. So we go with A as the option. Question number 4 here is, the statements below explain why magnesium is preferred over zinc to protect underground iron pipes in terms of reactivity, except for. So we have to find the reason why magnesium is preferred over zinc. So first let's try to understand what this element represents. If I'm comparing the property of the magnesium and zinc, magnesium is a more active element. And which elements are said to be active element? The element which can react easily and strongly with the other metals. Those are called active elements. And when we are comparing zinc with the magnesium, magnesium is more active because magnesium atom loses electrons more easily as compared to the zinc atom. So if you are involving magnesium with the iron, magnesium as a protective layer, so iron will be protected because magnesium is oxidizing and not by the reactions. So iron will be protected. But if you are using zinc as a protective layer or zinc as a along with the iron will be getting reacted more easily as compared to zinc, so that iron is getting oxidized and it is not getting protected. So to protect the iron pipes underground, so we have to use magnesium, not the zinc. So now which statement is the false over here? As we mentioned, magnesium is a more active element than the zinc, but the first statement saying that zinc is more active than magnesium, this is the false statement. So I have to say all other statements, whatever they are mentioning about the magnesium, is true except this, because magnesium is more active, not the zinc. So we should go with A as the answer. So second, they are saying magnesium atom loses the electrons more easily than zinc atom. That's true because it's more active. Magnesium oxidizes more readily than the zinc. That is also said losing the electrons, what we say, oxidizing. And magnesium is more active than the zinc. All these three statements are true about the comparison of magnesium and zinc except the first. So I have to go first as the choice. Question number 5 says calculate the mass percent of aluminium in the compound below. Round your answer to the nearest whole number. So how do we calculate the mass percent of aluminium in this compound? The mass percent of aluminium is the atomic weight of aluminium divided by atomic weight of the whole compound times 100. That's how do we write the basic definition for percentage. Percent is simply part over total times 100. So to calculate here, so mass percent, a percentage of aluminium, if I say, I would say atomic weight of aluminium, atomic weight of aluminium divided by atomic weight of compound, atomic weight of Al2, Al2SO4 3 times 100. That gives me the percentage of aluminium in that. That is the mass percent of aluminium. So we need to calculate the atomic weight of aluminium, atomic weight of sulfur, atomic weight of carbon, and how much they are involving in it, in this compound. So if we can see that in this compound, there are 2 atoms of aluminiums are there. Then what is the atomic weight of each aluminium? In that case, I have to refer a periodic table, because periodic, by referring the periodic table only we can calculate, because we cannot remember the atomic weight of all the elements. If this is the question, then definitely a periodic table will be provided to you, so you have to make use of it accordingly, take their values and do the calculation. So here, if I refer atomic weight of aluminium, how do we calculate? Let's refer to the periodic table. So from the periodic table, what I can observe that atomic weight of aluminium, here you can see that atomic weight of aluminium, it's representing here, atomic weight is 26.98, and in that compound there are 2 atoms of aluminium that are there. So the total atomic weight of aluminium, I do it as 2 aluminium atoms are there. I have to do 2 times 26.93. 26.93 or 26.98, whatever we are saying. So actually it is 26.98 as an approximate. That gives me value here as 53.96. Same way, if you look into this subscript 3 belongs to both sulfur and oxygen. So this is as good as there are 3 sulfur atoms are there in this compound, because this subscript belongs to both sulfur and oxygen. This whole number as a subscript 3 means there are 3 sulfur atoms are there. So what is the total atomic weight of sulfur in this? 3 times the S. So 3 times, know what is the atomic weight of sulfur from the periodic table again. Atomic weight of sulfur, you can see that here 32.066. We just take it as approximately 32. So let's say 3 times 32. So that gives the value here as 96. And how many oxygen atoms are there in this? Because this subscript should be multiplied with the subscript of the oxygen. This 4 is only with oxygen, okay, SO4. So we say this total number of oxygens will be 4 times 3, that is 12 number of oxygens are there. How we are getting that 12? Multiply this subscript with this. So there are total 12 oxygens are there. 4 times 3, that gives me 12. So there are 12 number of oxygen atoms are there, and you need to do 12, and the atomic weight of oxygen is 16, because this is the most common, or you can refer it from the periodic table. So you can see atomic weight of oxygen usually say 15.999, or I can say in short, the atomic weight of oxygen we can refer it as 16. So just make it up, make use of it. 12 times 16, that gives the total value here as 192. So now what is the total atomic weight of all this compound? The total atomic weight, when you add them, we're gonna get it as atomic weight of Al2SO43. That gives me total here as 341.96 atomic mass unit. So I'm not writing the unit. So anyway, it will get cancelled. So the total weight is going to be 341.96, but the weight corresponds to aluminium is 53.96. Just substitute over here. So we can simply do 53.96 divided by 341.96 multiply with 100. That gives us an approximate value here as 15.779%. But question says round your answer to the nearest whole number. We would round it to 16%. So aluminium corresponds to 16% of the weight in this compound. That is how do you calculate a mass percent of any element. So they might ask you with the different element. This is the way of answering to the question. So we go with 16%. Question number 6 here is, which of the following equations represents sublimation? So what actually the sublimation? Sublimation is basically the phase change due to the transfer of heat. And when we are talking about the phase change, some compound goes from solid to liquid, then liquid to gaseous, and there are some compounds which directly converted from solid to gaseous without passing through an intermediate state of liquid. And such compound, whichever they are converting solid to gaseous, the process which is converting solid to gas by supplying the heat, that is called sublimation. So we have to predict which of the equation is representing the equation for sublimation. So here you need to understand some other terms related with. Whenever we are writing the S in the bracket, so what it means, S represents a solid, okay, and G represents gaseous we say, L represents liquid, and sometime other type of also you could have it as AQ. So AQ represent the aqueous. So here, so it shows a carbon dioxide solid is converting into carbon dioxide gaseous. So how, why, we don't know, but we are just looking at the expression given to here. So this is the state which is directly transferring from the solid to the gaseous, and this equation is representing the sublimation. As I mentioned, sublimation is the state translating solid directly to the gas. So A is the right answer. If you look at to the all other options, liquid to solid, it's not, and gaseous to liquid, it's not, liquid to gaseous, it's not. So solid to gaseous is the sublimation. So we go with option A. Question number 7 is, given the equation representing a nuclear reaction in which X represents a nuclide. Equation has given to us which nuclide is represented by X. If you look at this, so 235U92 added with N10. So upper part always we represent the atomic mass, that is the sum of proton plus neutron, and the lower part we represent atomic number, that is the number of protons that element has. So when we are adding U with the N10, it means you are adding one extra neutron to this. So what will be the new element resulting? You just need to add the upper number with upper number here. It's gonna be 235 plus 1. My new resulting element must have this atomic mass as 236, and the number of proton added with 0. So 92 plus 0, it's gonna be 92 itself. So the whichever the element which is representing, it must be 92, and the atomic mass should be 236. So which element is representing? atomic number as 236 and atomic mass as 92, that is represented in option A. It should be U92 236. Question number 8 here is, which of the following terms used as a measure of the average kinetic energy of the particles in a sample? So they are asking us what is the definition of average kinetic energy. So let me tell you, average kinetic energy is basically the change in the temperature of the system. So imagine you have a container including gas in it. So if you continue to continuously supply the heat to that, so what actually happens, the gas molecules inside a container going with the more speed in a more random direction. So we can say that their average kinetic energy is increasing. So kinetic energy will be increased by increasing the temperature of the system. So we would say the average kinetic energy of the particle in a sample increases as its temperature increases. So we should go with A as the choice here. Question number 9 is, what is the total number of electrons shared in the bonds between the two nitrogen atoms in the following molecule? I don't know what this molecule represents, but question is about what is the total number of electrons shared between the two nitrogen atoms in a molecule. So let me tell you, whenever the electrons are shared, the type of bond formed between, we say them as a covalent bond. Again, it is polar or non-polar, it depends. But whenever the type of covalent bond is formed due to the share of electron, and one electron from this nitrogen atom, one electron from this nitrogen atom, they shared together to reach their octet state, and we represent them with the bond. It means one bond is equivalent to 2 electrons. So because they are shared, one bond is equivalent to 2 electrons. So how many bonds are there in the nitrogen atoms total? There are 3 bonds. So what will be the total number of electrons shared then? So 3 bonds times each bond represent the 2 electrons. So we say 3 times 2. Total there will be 6 number of electrons representing there. So we can see that the whatever the number of nitrogen bond occurring between, how many electrons they are represented by the 3 bonds. So we should say 6 electrons. So A is the choice. Question number 10 is, an elevator at shopping mall has a maximum load of 1600 pounds. LB we say it as a pound again. How many 75 kg persons can use the elevator at the same time? And they have also given us the unit conversion. So 1 pound is equals to 0.45359237. So we just need to calculate this 1600 lb represent how many kgs, because they are asking us a question, how many 75 kg persons can use the elevator at the same time. So this 1600 lb is representing what kg. So we can calculate the what total weight is representing in kg, and that total weight divided by the weight of each person gives us the how many person can be involved in the lift. So first let's calculate that 1600 lb is representing how many pounds. You just multiply 1600 multiplied with 0.45359237, it gives us approximately 725.7474 kg. So 1600 lb is equivalent to this much in kg. So how many people can go with this weight? So I just need to calculate. So number of people can go in an elevator. Simply we write it as total weight divided by, I can say total weight. This how do we calculate? Divided by weight of one person. So that gives us the total number of people can go. So total weight that it can hold is 725.745 approximate divided by 75. So if you do this, you'll be getting the answer here as 9.66 or 9.6766 something. So we can't say the number of people are in the decimal, and you can't even round it to the nearest integer. Whenever it comes in terms of people or things in terms of counting, always you have to round it to the integer, not the nearest integer, you have to round it to the lowest integer term. So 9.66, we can say it as 9 people. It can hold maximum 9 people. So I can't round it to the 10. It means it's increased in the weight. So it cannot. So I have to always round it to the lower integer whenever we talk about the things or the people in which comes in terms of count. So we go with maximum it can hold 9 people. So this is the answer. Question number 11 is the most simplest question, I would say. You just need to understand some theory behind it. They are saying the gold foil experiment led to the discovery of the dash. So who had conducted the gold foil experiment? It is not necessary to remember the name of the person, but let me tell you. The Rutherford was the person who conducted the gold foil experiment. What he did, he took a atom of a gold. Let's take this is representing an atom of a gold, element gold, and we didn't know that before him. We didn't know that something called the nucleus is present as at the center. So what he did, he allowed to fall an alpha particles, a helium particles in general. He was passing that helium particles through the gold atom. Some of the alpha particles or helium particle moves direct without deflecting. Some of the alpha particles hits the nucleus and bounces back exactly in the same way, and the sum of the alpha particles get deflected in their path. So this represents that there is something called positively charged is present something in the center of the atom, and then he gives that atom also has something called positively charged, and he gives the name it as nucleus. So the gold foil experiment led us to discover of the nucleus. That is how it has been conducted experimentally. So alpha particle or helium rays, which is allows some they goes direct, some they reverses back, some they go deflected with a certain angle. From that we can predict that there is something, a positive charge is present, and which we say it as nucleus. Question number 12 here is, which particles are found in the nucleus of an atom? It seems the continuation of the previous part. So let me tell you this. Let me show you the structure of an atom, how it looks. Atom looks like this. So this is how the atom is made. Electrons are revolving around the atoms, around the nucleus in an elliptical orbit, as we have shown. And nucleus is the composition of the neutrons and the protons. So nucleus are made up with the combination of neutrons and the protons. So we can say that nucleus consists the neutrons and the protons as the particles. So we should go with protons and the neutrons are present in the nucleus of the atom. So go with option A. Question number 13 here is the below graph for a substance being heated from minus 50 degrees Celsius to 600 degrees Celsius. The graph has been shown for the certain substance which is heated with from the temperature ranging minus 50 degrees Celsius to plus 600 degrees Celsius. So here y-axis of the graph is representing the temperature in degrees Celsius, and x-axis of the graph is representing what? Absorbed energy in kilojoules. And this is how the graph has shown. So here the graph is not clear, but I just analyzed it carefully and I've found that whatever the value they have written, they are multiples of 100. This is gonna be 100, this is 200, 300, 400, and so on. That all gives like 500, so on. And temperatures are in terms of minus 50, 0, 50, 100, 150, 200, 250, like increment by 50. Now what question is asking us? Question says if 600 kilojoules of heat are removed from the substance when it is at 350 degrees Celsius, what will be the state and the temperature of the substance? So initially the substance temperature is 350 degrees Celsius. I need to, by reading the graph, I need to understand what amount of energy it has there in that at that temperature. So 350 degrees Celsius, you can see that this is representing 350 degrees Celsius as the temperature. At that point, read it like what amount of energy the substance has. The amount of energy it absorbed at that point is gonna be, we can say, come just down straight. You can observe here is this is the amount of energy. What this value is representing, as we say, this is 600, this is 700, this is 800, this is 900, 1000, and this is 1100, this is 1200, and this value is representing 1300. So if you decrease 1300, if you decrease this energy by 600 kilojoules, so what is the energy left then? So we can say 1300 minus 600 kilojoules of energy releasing gives me 700 kilojoules of energy left in that. So when the 700 kilojoules of energy that substance has, what is the temperature and what is the state of the substance they are saying? So where is the 700 kilojoules? Here I can say correspondingly look at what is the state and what is the temperature. What I can predict here is the temperature of the substance here is going to be 250 degrees Celsius. And what is the state? The state for this one, we need to understand what this graph is representing. This graph is representing simply a phase transfer of the element or a substance due to the supply of heat. And if I represent that it in terms of phase transfer graph, we can see that this is how the graph is representing. The first part is representing a substance is a solid, and when you're continuously supplying heat energy to it, it is trying to convert into another form called the melting. So this is melting, and during this course, the temperature is maintained constant here. During the process of melting, the temperature stays the constant. It means this is the property of every substance and element. Whenever the temperature is applied to the substance, two things can occur. Either the temperature of that substance changes, maintaining the phase, or phase of the substance changes, maintaining the temperature as a constant. So either one happens at the same time. When the solid is transferring towards we are continuously supplying the heat to this, its temperature is increasing, its state stays the solid, and further when it is converts from solid to the liquid, it start melting by maintaining its temperature. Then liquid state goes from to the gaseous again by increasing the temperature, and so on. So if you look into that, first represents the solid, then liquid, then the gaseous or a vapor. So if you look at to the question what they have given, this state must represent a solid, and this is the melting and freezing, whatever it comes. This state represent the liquid, and this state represent the gaseous or vaporizing something. So what is this? What is representing? The substance must be in a liquid form with the temperature of 250 degrees Celsius. So I should go with the option which says liquid with the temperature as 250 degrees Celsius. That is what match up with option A, liquid at 250 degrees Celsius. Question number 14 here is the equilibrium constant K for the following reaction is 1.5 into 10 to the power plus 5. This is the reaction they have given to us, and there are the equilibrium constant for this is given. Based on the above information, the reaction at equilibrium will always be, so larger amount of product, larger amount of reactant, 75% product and 25% reactant, and another option they have given here as 50% product, 50% reactant. So how do we do this? It's basically a simple calculation. How do we write the equilibrium constant? Equilibrium constant, we usually write it as K, or sometimes we refer it as Kc, is basically the concentration of the product divided by the concentration of the reactant. This is the way of representing. So if you know the concentration of product, you can calculate what is the concentration of reactant by knowing the equilibrium constant. And if a question is based on the above information, the reaction at the equilibrium will always have. They are asking us the relation between the product and the reactant. This equation I can modify mathematically as, if you just take x to the other side, it's just like simply doing the cross multiplication. So Kc time a concentration of the reactant is equal to the concentration of the product. So I can see that product, whatever it is generating, K times the concentration of the reactant, and we know the value of K is larger in value. So 1.5 into 10 to the power plus 5, it's very big value. So very big value multiplied with the concentration of the reactant, that gives me the concentration of product will have greater in value as compared to the reactant. So we should go with large amount of Y produced. So because it's getting Y is basically K times the X. So X multiplied by K, that gives me the huge value, because the value of K is very large. So we should say large amount of product Y produced. A is the right choice here. Question number 15 is, a student conducted a titration by adding 12 ml of sodium hydroxide aqueous of unknown concentration to 16 ml of 0.15 mole hydrochloric acid. What is the molar concentration of sodium hydroxide? This is basically an experiment, like what we say titration. So titration is simply a drop wise adding to like adding an unknown solution to find the concentration of it. So here they are saying that a student is conducting an experiment which is titration by adding 12 ml of sodium hydroxide of an unknown solutions to the concentration of this of the hydrochloric acid. So now what is the molar concentration of that? So let me tell you, to find the molar concentration, I should say the molarity of the substance, or I can say the molarity of the substance times the volume of the substance must be equal to molarity of the titrant times the volume of the titrant. So whatever the titrant, whatever the substance, they should be equal as per the molarity, as per the conservation of energy conservation law, what we say. The molarity of the substance times the volume of the substance must be equal to molarity of the titrant times the volume of the titrant. Now what is the titrant here? Sodium hydroxide, and we are asked to what amount in mole. So we have to calculate the molarity of the substance. Here is 0.15. So I can say the molarity of HCl times volume of HCl must be equal to the molarity of NaOH times the volume of NaOH. So that is what we're gonna look. Substitute their values. So far we have all. So molarity of HCl, let me just continue here. Molarity of HCl is 0.15 mole times the volume of HCl, here is gonna be 16 milliliter, equal to molarity of NaOH, we don't know, M of NaOH we are finding, times its volume is gonna be 12 milliliter. Just simply by doing the simple math, divide both the side by 12 milliliter, what are you gonna get? So you'll be getting that value here as molarity of NaOH will be, so 0.15 times 16 divided by 12, that gives us 0.2 mole. So answer here is A. Okay, so that's with all the sample questions. Sometimes student ask me saying that why every like only options are A. Should I choose A as the option in the exam if I don't know, or all as A? So I can't say like any answer to that, because the question paper here, it is a sample paper and they have modeled it in a way that all options gives A as the choice, but in exam it's not necessary every options are A only. You have to solve it and you have to get it. Okay, don't get confused saying everything I have to go with A. This is just a sample paper, so we are just solving and we are just looking at according to the what option has been given. So in exam it will be different. All right, that's it for today. Thank you.